Welcome back, everyone. We are starting chapter 3 today, and we are starting with functions. A relation is a mapping or correspondence between two sets. Now, typically what we have, and what I'm drawing out here is actually called a mapping. We have two sets of numbers. Doesn't matter what the numbers are. And where we start is with the domain, usually represented with the letter X. And in this domain, we have 3 and -4. And in this range, which is what this second one is called, we more often than not call that Y. 5, -2, say. And what we have, this mapping, is how do we get from 3 to 5? We have a function. And it tells us to take something out of the domain, change it somehow. The function, it's going to change something in the domain the same way every time. And you can see this particular function is adding 2 to our domain. So take 3 out of the domain, function it, in this case add 2, and we get 5 as a result, the range. The domain is what's called the independent variable. The range is called the dependent variable. So the range depends on what X value is chosen from the domain. And let's go through some of the characteristics. A function is a mapping that assigns to every element X in a set A exactly to one element Y in set B. The set A is the domain of the function, and B is the range of the function. That's what I just explained. Let Y equal f of X. And this says that Y is a function of X. Now, this does not mean f times X. This is just saying the function is going to control how to change the domain or the X value, and the result of that change will give us a range value or a Y value. And as I mentioned, X is the independent, Y is the dependent. And in different types of classes, they may have different names as we do this. Let's do an example. We want our function to take a number and multiply it by 4. So here is our function. F of X equals 4 times X. So you give any X value you want to the function F. What's its job? It's going to multiply by 4 every time. And in this case, the domain of F, there are no restrictions. And we'll talk about some restrictions here in a minute. And the range is also unrestricted. -infinity to infinity for both. Now, the main restrictions that we're going to be running into when it comes to domain are potentially dividing by a negative, or taking the square root of a negative value. Dividing by 0, pardon me, and taking the square root of a negative. And in this case, we have the danger of both. So for sure, X cannot equal 5. If X equals 5, I get 5 minus 5, I get 0 in the denominator. That's bad. So 5 is definitely not in the domain. We also know that X plus 2 has to be bigger than or equal to 0. It can equal 0. I can take the square root of 0 and not have any problems. But X has to be bigger than or equal to -2. And I want us to take a look at a number line. Basically, what we're going to have, because we're including 2, it's going to be a solid dot. It's going to be everything bigger than that, except we have to skip over 5. So how do we write that in interval notation? It's going to look like this. -2 to 5, and then 5 to infinity. What this is doing is we're saying from -2 and on, we're good, except we got to skip over 5, which is exactly what we would need to do here because we can't divide by 0. All right, example 3. Let's find the domain. Here we have a discrete function. And the domain in this case is going to be 3, 7, and 20, meaning it's the X values. The range in this case is 2 and 5. We don't need to repeat the 5 a second time. All right, moving on. Find the domain for each of the following functions and answer in interval notation with exact values. Yeah. So for part A, what I'm going to have to do is I'm going to have to factor the denominator because I can't divide by 0. So I'm going to take this denominator, I'm going to pull a 2 out. and factor it. So this tells us that x can't be 7 or 1. And if we want to write that in interval notation, that's going to be negative infinity to 1, union with 1 to 7, union with 7 to infinity. So there is the domain. Right now, basically, we're negative infinity to infinity. Anything's fine except 1 and 7. We have an issue. And for part B, the 2x squared minus 16x, 16x plus 14 has to be bigger than, strictly bigger than 0. It can't even equal 0, right? Because then I'll be dividing by 0. So we know this factors to this. And the way we test this, here we have 1, 7, and we silo this off and test a number less than 1. I like 0. Let's try 0. When I plug in 0 to here, I get 2 times negative 7 times negative 1, which is a positive 14. Now, the point of this is that it is positive, bigger than 0. I'm going to pick something now between 1 and 7. Let's pick 2. So 2 times 2 minus 7 times 2 minus 1. 2 times negative 5 times 1. That's negative 10. And the point is the sign. In this case, any value of x that I plug into here is going to make it negative. And I'm not looking for negative, I'm looking for positive. So let's test something bigger than 7. Let's do x equals 8. 2 times 8 minus 7 is 1. 8 minus 1 is 7. The point is, any x value there is going to make it positive. So what's our answer in interval notation? Our answer is going to be negative infinity up until 1, and then 7 and on. This is our domain. So we have to skip this whole middle part here. All right, next part. Determine whether the equation represents y is a function of x. The answer is definitely no. When I solve for y, I end up with plus or minus the square root of 3 minus x squared. And the reason it's not a function is because we're getting 2 different values here. So each x value is going to give 2 different y values. So the answer is no. You can only give 1 x value by definition. Yeah, so let me write that out. X value gives 2 y values. All right, so part A, f of negative 3 means I'm going to replace each of these x's with a negative 3. Be careful here. We've got a double negative going on. That's just 17, it looks like. Part B says f of x plus 5. And I'm going to go ahead and FOIL that out. Here I'm going to distribute a negative, minus x minus 5 plus 5. Combining up the like terms, I get x squared. 10x minus x is 9x. Looks like plus 25. Part C is a little more involved. Screw this up a little more. So f of x plus h is going to be x plus h squared minus x plus h plus 5. I'm going to FOIL that out. And nothing combines up there. But we will be doing this more on the next page. All right. We are now to something that's very important. This is called the difference quotient. This is the origin of calculus, actually. This is the very, very first place you go for calculus. And so it says f of x plus h minus f of x divided by h. Now, kind of the goal is to get rid of that h in the bottom there. In calculus, we're going to want to make h equal to 0, and we can't do that so long as it's in the denominator, because that's not in the domain, right? So let's start here. So we're going to do f of x plus h equals 3 times x plus h plus 5. So let's do it. So f of x plus h, that's 3x plus 3h plus 5 minus the original function, that's 3x plus 5, all divided by h. This becomes 3x plus 3h plus 5 minus 3x minus 5. And you can see the 5's go away and the 3x's go away. And as I said, our kind of goal is to get rid of that h in the bottom. Part B is a little more involved. So let's. So here I'm going to go x plus h squared minus 4 times x plus h plus 1 minus the function x squared minus 4x x plus 1 all divided by h. Let's see where that takes us. You can see 1 is gone, 4x's are gone, the x squareds are gone. We're left with 2xh plus h squared minus 4h over h. And can you see I can factor out an h from each of these? There's my answer. All right, now part C gets even more crazy. So this is going to be 3 over x plus h plus 5 minus 3 over x plus 5 over h. And I'm actually going to multiply the top and bottom both by x plus h plus 5 times x plus 5, the top and the bottom. And we're not going to FOIL that out. We're going to keep it factored. That brings us to 3. Now, all that cancels there. I'm left with the x plus 5. And here the x plus 5's cancel. I'm left with 3 times x plus h plus 5 all over h times x plus h plus 5 x plus 5. I'm going to distribute up top. I'm going to move this down a little bit. 3x plus 15 minus 3x minus 3h minus 15 all over h times x plus h plus 5 x plus 5. And I'm going to notice 15 minus 15 is gone. 3x minus 3x is gone. We're left with a negative 3h divided by h times x plus h plus 5. And you'll notice, finally, our h goes away. And I'm going to have to write that here. Negative 3 over x plus h plus 5 times x plus 5. Whew, crazy, I know. Our operations with functions. This means we're adding the functions up, we're subtracting, multiplying, and dividing. So let's do our example here. Part A says f plus g of x becomes f of x plus g of x, which here is 4x squared minus 5 minus x plus 3. Yep. And then part B is multiply. So I'm just going to FOIL. Plus 12x squared plus 5x minus 15. And I don't think those combine. Nope, they're all like terms. This one, they're actually looking for find the domain of f of x over g of x, which is going to be 3x plus 12 over negative 2x plus 8 divided by that, which means take the reciprocal. And this actually becomes here, and our main concern and this should be 15. 15 times 3 times x minus 5. So our only problems in this case is that x can't be 4 or 5. So how do we write that out? Anything but 4 and 5. So once again, remember, when you divide the two, you have to take the reciprocal of g. That's why it's flipped like that, to make it multiply. All right. Hope that helped.